Hello, welcome back. So in the last video, I told you I would be trying to set myself up to be able to perform the land use land cover analysis. And what I needed to do was set up this kind of folder structure where I downloaded the Python notebook. I set up a folder called futures, which had the utilities.python file, which has all the functions we would need to get the geodata and plot it and analyze it and create the outputs that we need, like files on land cover type and total percentage forests. Set up the output folder where this script will start producing these files, and set up a folder for the shape files. That is what I have done here. And now I'm going to be bringing in the shape files that we need for the analysis. So we definitely need RR because that is what we use for Mozambique, right? So I got an RR. The next thing we need from here, from this shapefile repo, is Benakat, right? And we need Benakat. So let's bring Benakat, right? And we're gonna need Supanjariji and Martapura. So we're gonna bring those two as well, which are basically at the component level. I'm wondering if we need to do it at the total level for all the 16,000 hectares in Indonesia. I think that could be a good idea, so I'm just gonna go and bring that as well, so that we have breakdowns should we need it, but we also have the total picture across Indonesia. We know that polygon is called HCF land cover 16,000 hectares. So I'm just gonna bring that in just for the purpose of the Python script, because you gotta write the reference for where the files are. I just don't like the way this is named, so maybe I'll just rename that as 16,000 hectares, so it's much easier. Now that we can't refer to the whole name for it, just having a simpler name means you'll be able to understand the code a little bit better when I set it up and show it to you. So this is a simple renaming exercise just to get things in order. Okay, so we are, oh, I made a mission. Alright, so now we've completely renamed these files and we can refer to them from the Python script. So I need to, I seem to have a Jupyter kernel running, so I'll close that. I need to open a new, and I'm already in my Google Earth Engine Conda environment, and that's what I need because that is where I have all the Python libraries that I need for geospatial analysis stored. So I'll just navigate into the land cover folder that I've set up above here, and I will just restart a Jupyter notebook to be able to access and set that up for analysis. So as you can now see, this Jupyter notebook has now been loaded, and I'm just going to open it. So as you can see, all we're doing in the start is importing the libraries that we need: pandas, matplotlib. From futures, the folder that I set up, I had set up a file called utils.py, and I'm going to bring that in as futures utils fu. Geopandas as gpd, shape leader geometry as shape. I need to list all my shape files here and give them short names so that it's possible for when the output files get saved in the output folder, they will use this name here. As you can see, we've handled simple and complex file names, but I'll just exactly set this up now with the file names that we need. Right? So within shapes, we have rr.shape, and I will just call that Mozambique RR. And the last input you see here actually is the EPSG code uh, in order to compute areas using Shapely. So we know that for Indonesia we were using 23830. So let me grab that and just keep that there for Indonesia. I just want to go back and check what we were using for Mozambique. If it was still here, no, but that's fine. We'll just search for it. So for Mozambique 27, I believe this is what we were using. We need a convention that is, I don't know what this. Okay, we need a convention that's in meter. Yeah, so we have that. And so we'll use EPSG 2736 for Mozambique. Right, so I'll bring that there. Then here we really need Indonesia Benakat. We need Indonesia Suban Jeriji. I think they. So I'm going to call this BNK because that's the kind of short forms they have been running with for other data sets uh, that they have shared with me for Indonesia. Indonesia.martapura, I'll just call it MRT. So we have that going. We know that the name of the file here is Benakat. You know, this one is, it's not really Zimbabwe or anything. It's Subanjeriji. Right? And we know that this is Martapura. Right? So we have all that going here. We can just get all this. This is an entirely different project. Okay, here we are. So let's see this. Last enter. So this just creates a list of all the shapefiles. And this simply just allows me to print and check the elements of a list. I don't really think I need this at all because it's so easy to observe here. Next one shows me the list of, like, it's trying to generate the modus land cover stats from 2010 to 2020 for all of these shapes, and it's saying it wants to go from range 48 onwards, and I don't think that we should do that. We need to go from range of until the entire length of all that we have here in the shapes list. So it'll kind of identify the shape file, and then it'll identify the the plot is the name of the plot that we have here, which is element number 1, and element number 2 is the APSG code. We don't really need that for now. And then it'll kind of be able to tell you that it's when it starts working on the plot that it's working on. That start date is a list of start dates for which we actually want to crunch the modus stats. So for a zoom level of 12, we'll pass in each of those start dates, and then we will run the analysis modus yearly land cover map. We will get it using futures utils by passing in the date, the shapefile, a name for the plot that we want, and the zoom level. And the futures utils will automatically go and save a file for each of these start dates in the output folder. Next thing we want to calculate here is hectareage. So we would know that the shapefile comes from the first element in that list. The EPSG code comes from the second element here. And here basically we want to be able to we read the shapefile and we set the CRS, and we use Shapely's library to calculate this area. And what we're doing here is kind of converting from square meter to hectares. We round it to 4 decimal places and we look at it. So that is how we get hectareages that we have used in the past. And we'll compute this for each of the polygons and corroborate using our other estimates we've got directly from the field and from QGIS. And here we have, we're going to work with modus land cover classes. So these are the 17 different modus land cover classes that come from this modest data set, right? So LC type 1 is the band we're actually importing. And this is the class table for LC type 1, land cover type 1. So we have 17 land cover classes, of which we know that the first 5 are forest, right? So that's the way this works. We get the dictionary of all the forest types. Then we check the current land cover type. For some reason, I set a counter here because I think I needed to work with shapefile number 41. We'll work past that, don't worry. We got the shapefile, we got the file. We want to print the list shapes of counter. All right, we're doing this at a per shape level. So at for each shape, we want to look at the current land cover. That means we want to look at the 2020 file, latest one for which modest data is available. See, it ends in 2021. So 2020 is the latest one that's available. We want to look at that and use that as a current land cover map. So we will go there and we'll create a sum of the percentages by the class type. So we'll know, it'll kind of generate a table like this, which will show how much of each land cover type we had in 2021. That becomes a very important piece of analysis. And then we'll check the 2010 land cover type just so we can build change detection, right? So we want to check how much forest cover has changed, etc. And sometimes we want to optically look at the land cover in 2010. So this is just us looking at 2010, and it says TTLC is equal to, right? Okay, so just checking 2010 land cover type for the same thing that we had there. Great. So this then looks across. This is an interesting piece of script where for it'll go to each of those years and it'll add up all of these first 5 types. That is evergreen needle-leaf forest, broadleaf forest, deciduous needle-leaf, broadleaf, and mixed forest types to generate a total of percentage forest, and it'll compare that percentage forest year on year in order to then give you 3 pieces of information, which are average. This will give you like a list of forest cover and deforestation rates for each of the 10 years, and this will give you average annual. It'll give you 10-year deforestation rate and 5-year deforestation rate. These are important things that we'll need to consider. The next 2 pieces of information seem to measure statistics for NASA Oak Ridge National Lab. It is generating above and below ground biomass estimates that we then use to derive a total biomass density to evaluate carbon market tonnage. So it'll kind of, this futures utils gives the method to go and evaluate that from the NASA Oak Ridge National Lab dataset and put it into the outputs folder. So that's what I'm setting up for. I want to run that across all the shapes from 0 to the entire list of that shapes list that we created. And here I want to check specific stats only for certain shapes. So the counter we are looking at is here, so I just need to set that each time we're at it, and we'll be able to generate the stats for the table that we need. The other test estimate that I generate, you see here, is called, apart from our below ground biomass, we also need soil organic carbon as an estimate to kind of determine the total biomass density of the land. So I will also get some working estimate of that from a dataset called Envirometrics Open Land Soil Organic Carbon. And that is at 1950 to 2017 average. Yeah, it's a little bit dated because it's 2017, but it's still okay to have because it's a long-term average. So I'll keep that in there for our analysis. So we have this going, and we can also, I'll kind of estimate the soil organic carbon from that multi-band image with a 1 meter depth and a 2 meter depth. So that's something we'll do. And the other thing I sometimes want to save here is I want to save Uh, I look at modus land cover stats not just from 2010 to 2020, also from 2001 to 2009. And this is mainly because I want to see what is the sustainable level of forest percentage that that land has been able to hold in the past. This will inform my estimate of a reforestation percentage level that I can target. So in order to build what is a sustainable target, I want to calculate these as well and put it in the output folder. Features util gives us the code to do that, which I've written. It's a Python package. Um, and then finally, from that, it'll generate, average percentages for those years, those historical years, uh, which I think I want to retain as well. So once again, we need to look at that plot by plot so we can change this at the right time. Uh, that's great. So then after once we have all of these things going, it's just up for us to be able to generate these numbers and make some guesstimates and derive that estimate. So we'll need that. So we're almost ready to start running this script. But before that, I want to open up another tool that is called Global Forest Watch. It's a database that many investors use to kind of get biomass density of the land. But I really think that the data they have is quite outdated. You see, tree cover gain, they have it till 2020. And if you look at climate, right, I think this is where they have tree biomass density. Oh, okay, it's actually been updated to 2021. The last data set they had was of the order of 2009. So they actually have newer data at this point. So it's quite exciting. Um, we're going to use that to determine biomass density. We're not going to use any of these other change detection algorithms. But I see they have new data sets like Hansen from UND, etc., already incorporated into the C21 2001 to 2019. So it's great that Global Forest Watches had a refresh. But I mainly look at tree biomass density and soil organic carbon to get a total organic carbon estimate for this. And I will typically need to build some estimate of that for South Sumatra and for Mozambique, so we can use that. Mm, just gonna hold on to this for now because we need to refer to it at different stages. But I think we're slowly getting to a position where we can start running this Python code book. Um, I'm just creating space so we can start looking at these. I'm going to close things that we do not need. We don't need this dynamic world level hold on to because it's something we'll do after. So I want to do a quick time check at this point, 18 minutes. I think it's a good place to stop and I will start executing the Python notebook and bringing each of those elements onto the slides. We're doing well. Okay, see you in the next video.